Hi, I'm a new age server alarm, and this is going to be Fun Facts, episode 5. Number 5. So, I'm currently in the parking lot of the main mall in South Portland, Maine. And I just went to the Apple store. Because my MacBook had a broken key. For a fun fact for everybody, the Apple store sells replacement keys for MacBook, MacBook Pro, and MacBook Air keyboards. You can get a replacement key for free. Did I say sells? Okay. Anyway, so, time to go home. So what am I going to talk about today? Oh yeah, there was one last little story that I was going to mention that I didn't mention last time. Somebody said in the comments of the last video, should have told this story, so I'll tell it. I was doing the same hospital with the chime strobes that wouldn't stop, alright? I told about that one in the last video, the 4100U system that totally failed. So here's what happened. Later on in the day when we were still doing the horn strobe test, I got up to the 3rd floor, and... Go ahead, ladies. Go ahead, ladies. Got up to the 3rd floor, and I saw a series of operating rooms and a bunch of classrooms. The 3rd floor was being used as a medical school with simulated operating rooms. And they use that for simulated procedures on mannequins and stuff. Well, horn strobes are going off. It's fairly dark in this section of the building. I walk into a room. It's kind of a large room. It's dark inside. Then the strobe light on the true alert in that room flashes. So, and when it flashes for like the blink of an eye, I see what looks like a body strapped to a table with an oxygen mask on. And I'm like, what the was that? So strobe flashes again, I see it again. Then I eventually find the light switch. That was a simulated operation that I guess they were doing but then stopped for some reason. So I thought that was freaky. That scared the crap out of me. Just walking in on a room with a body strapped to a table. I mean, it was a mannequin, but still creepy. And then later down the hall, it happened again with a closet full of mannequins. Guess that must have been their mannequin closet. But I opened up the door and there were a whole bunch of bodies just laying on the floor. And the strobe light lit them up for a blink of an eye again. I was like, what the hell? Scared the crap out of me. So, funny story of the day. Alright. Now I'm going to answer the question from the last video. The question was actually a few questions. First one was, what is the minimum strobe light intensity required for a strobe in a sleeping area? Second, what is the minimum horn volume for a horn in a sleeping area? And third, where are these two measurements made at? Here are the answers. The answer to the first question is 110 candelas. At least 110 candela. The answer to the second question is 75 decibels. The answer to the third question is at the pillow. Okay? These measurements are to be made at the pillow, which means if you need to put a strobe in a sleeping area, it'll probably have to be more than 110 candelas. And they do make high candela strobes exactly for this purpose. So, now, here's another thing. Here's another question of the day for you. What is the new 520 Hertz low frequency requirement? Well, I'll just answer this one. The 520 Hertz low frequency requirement is a new requirement that's slowly being adopted in the country. States that have already done it are Vermont and California, and a few others I don't remember off the top of my head. Vermont was ready for it as soon as it got implemented, though, but the other states are just taking a while. Pick a lane. Thank you. Anyway, so the low frequency requirement is that they did studies, sleep studies, where they compared different types of stimuli to wake people up while they're asleep. The first one they tested was the standard smoke alarm frequency, which is 3,100 hertz. Oh, screw you, traffic light. Seriously. Couldn't let one more car go? Or two more cars? You had enough time. Anyway. Anyway. 3,100 hertz. They tested it and they found that it does not have enough. It is not loud enough to wake up most people, which isn't really that good, I guess. Wasn't enough to wake up most people. So then they tested some more things, such as bed shakers, and that didn't do so well either. They also tested 400 hertz, and they tested 520 hertz, and they also tested strobe lights. Okay, 400 hertz worked pretty well, but 520 hertz had the highest success rate. Now, strobe lights didn't work so well either, because if you're a heavy sleeper, you're not going to see the strobe light flashing. So, 520 hertz is what they found to be the most effective at waking up the most people. And the kinds of people they tested this on were children and elderly people, hearing impaired people, and intoxicated teenagers, and intoxicated young people. That's what they tested it on, and they found 520 hertz had the highest success rate. So, that was good. So if you need to wake up, so if you live in a house and you have a large family with kids, get a 520 hertz sounder. It'll wake them up. So, yep, that's the new requirement. Now, today's topic. Now I'm done with the little fun facts. Now today's topic is going to be about the basics of addressable systems. I'm not really going to go into the history of them. I'm just going to go into the basics. Because a lot of people don't know about addressable systems, and it's not easy to find out a lot of stuff about them. So, I'll go into the basics about it. First of all, addressable systems have modules and detectors. Modules are small devices that wire up to the system. But before I get into that, I have to explain the addressable data bus, called the SLC. SLC means the signaling line circuit. And what that is basically a two-wire pair of wires that carries both power and data. And it alternates the power and the data at a very rapid rate. Funny how there's a do not enter sign and a wrong way sign, even though I'm on the right side. Anyway, so that's addressable SLC. Well, thank you, Easy Pass. Anyway, that's the SLC itself. It alternates the power and the data. So what happens next is you've got devices on the SLC, such as detectors and modules. And what these do is they communicate their status over that pair of two wires. They constantly push their status out to the panel. The panel takes readings. And what happens is, in the case of a detector, instead of a normal conventional detector where the smoke detector processing algorithm is inside the detector itself, where the detector itself makes a decision whether it should go into alarm or not, instead what addressable systems do is they take that detector reading and send it to the panel. And then the panel decides whether it should go into alarm or not. Whoa! Put a lid on that thing. Jeez, the criminals. Little rocks flew out of that dump truck over there. Anyway, so that's the SLCs. Anyway, so yeah, that's SLCs. They're detectors. Sorry, I got distracted by the dump truck throwing rocks at me. Anyway, that's what detectors do, is they put their values to the panel. Now, this may seem convoluted, like why can't you just do it in the detector and then tell the panel that there's an alarm? Well, the reason for this is you can do different things with the sensitivity reading, the sensing readings of the detector. First one is called time, or schedules, time schedules. Alright. How this works is the SLC, or the panel, is able to read the detector. Oh my goodness, sorry. The panel has a schedule on it where it can turn down the sensitivity of the smoke detector during the day. One example of where this could be applied is in a gym, not a gym, I mean in a shop, or backstage on a theater during a performance. Now, in a shop, you got lots of wood, you got lots of sawdust, you got lots of stuff that could set the detector off, so if that shop gets used regularly, you can program the system to turn down the sensitivity of the detectors to avoid them going into alarm by accident while the shop is in use. And then at night, after the place closes, you can turn the sensitivity back up so that if a fire occurs during the night, it'll go off sooner. So, now, there are lots of regulations for decreasing sensitivity, and I'm not going to go into what those regulations are, but that is one application for why you'd want to send the readings to the panel. Another application is a feature called cross-zoning. Well, sort of. It's sort of cross-zoning. What cross-zoning normally is on conventional systems, cross-zoning is, it takes two detectors, it waits for two zones with smoke detectors to go into alarm. Two zones, they'd be in the same area, waits for both of them to go into alarm before it sounds the signals. It's to reduce false alarms. But you can do something similar with addressable detectors. You can use two addressable detectors installed near each other, and you can program the panel to wait until the readings from those detectors get high enough to cause an alarm. So, yeah. So yeah, that's detectors. And of course, they got smoke detectors and heat detectors and stuff. Now, it's a common misconception that you can set the temperature of a heat detector by programming a value on the panel. On most systems, this is actually not true. You have to buy a detector that's rated for that temperature rating. So, yep. Oh boy, construction again. Boo-hoo. I hate construction. Wow, this is tight. Why is the lane split anyway? Must be a hole there or something. Look. No, there's nothing there. So I wonder why they split the lane. Anyway, so that's, yeah. What was I talking about? Oh yeah, heat detectors. So you have to buy a heat detector rated for the temperature value you want it to be. So that gets a little bit annoying at times, but I mean, for collectors it's annoying because you can't play around, but for installations you're going to need that type of heat detector anyway, so it doesn't really matter for them, I guess. Moving on. Now I'm going to go into modules. And modules are simpler than detectors. And there's four basic types of modules. You've got what's called a monitor module, or also referred to as an input module. And what a monitor module does is allows you to connect a contact closure device to the SLC loop. A contact closure device meaning the switch on a pull station, or a water flow valve, or a tamper valve in a sprinkler system, or any other thing you need to input to the panel with. You could even have a security system that causes the door holders to drop and lock if you wanted to. Send a signal to the fire panel and drop the doors with a monitor module. So, yeah. Next type of module we got is called a relay module. And this is a dry contact output module. Now what that means is you can wire something to it that gets turned on by the panel or turned off. A common use of a relay module is to shut down duct detector. A common use of a relay module is to shut down air handling units in ductwork after a duct detector goes off. Another common use is elevator recall, where you got relays which trip the recall and make the elevator drop. Which brings me to the question of the day. Elevator recall. A lot of people know what elevator recall is. Basically, when the system goes into alarm in certain positions, the elevator drops to the first floor, it opens its doors, and shuts down. That is called primary recall, okay? The trivia question of the day is, what is secondary elevator recall? Post your answer in the comments and I'll reveal it in the 6th video. So anyway, so yeah, that's a relay module. Now for control modules. Control modules are like relay modules, except they require a separate 24-volt power source besides the SLC loop itself. And what a control module does is sends that 24-volt power through it and essentially becomes a NAC. A common way control modules are used, or signal modules are sometimes called as well, is when you need to do selective signaling in a hotel room or an apartment where you only want to set off signals in that area. You use a control module to control them. So, now the last type of module is called a zone module. Now a zone module is different from a monitor module because A zone module requires a separate 24-volt power source. But what it does is it creates a 2-wire detector loop and basically creates a conventional zone that you can wire to an addressable panel. Now, zone modules come in singles, or they come in cards which have multiple zones on them, which wire to the SLC loop. So, and they're often used for retrofits and other things. So those are the 4 basic types of modules. They've also got some variants on the modules, such as a input-output module, which is both a monitor and a relay in the same one. And they've also got telephone modules, which are used for controlling firefighter telephone communication circuits. And they've got speaker circuit modules, which are similar to control modules, except they control audio signals instead of NAC power. So that's mainly used in voice evac systems. That is toll booth. 2 toll booths today. Ding, fries are done. Ah, LED traffic light. Anyway, so now there's another type of module that isn't actually an SLC device, like it doesn't talk to the panel. It's called an isolator module, or the long term is a fault isolator module. Now what that does is it's constantly scanning the circuit to look for short circuits, ground faults, or anything that would compromise operation of the system. And when it detects one of those faults, it disconnects that portion of the circuit, isolates it from the rest of the system so that the rest of the SLC loop can stay functional. And yeah, of course it puts the panel in trouble because the devices suddenly go missing, the panel can no longer talk to them. So, as isolator module. Now, here's the thing about SLCs. A little bit of history. Not a lot, a little bit of history. Older SLC circuits, because they were a data bus, required that you use shielded twisted pair alarm cable. Now what twisted pair means is the alarm cable has pairs of wires and they're twisted together tightly, like an Ethernet cable. And shielded means there is a metal jacket over the wires to keep electrical interference out. Now, modern SLCs no longer need shielded twisted pair. You can actually just use straight pair like lamp cord now, because the quality and the reliability of the electrical systems in these types of loops has gone up significantly. So, way back then, SLCs were addressable systems. Way back then, could only be installed in new buildings because you had to run shielded twisted pair. But now you can put an SLC into a building with really old wiring and it'll still work, which is nice for retrofits. Such as when you're cutting over a panel, a conventional system to an addressable system. So, now there are a few problems with SLCs compared to zones, and there is one advantage that SLCs have over zones. The problem is that you can't short an SLC. You cannot wire any conventional devices to an SLC, not at all. If you wire a pull station to an SLC loop, when you hit the pull station, it's going to short the loop, and it's going to shut down the data stream, put everything into trouble, and then you're done. No power, nothing. Nothing's going to work. Hang on, I gotta pull over a moment. My iPhone's been having a tendency to randomly stop recording, so I just wanted to make sure it's still recording. Oh good, it's still recording. Hope I didn't just jinx it though. Anyway, back onto the road. So yeah, another problem with SLCs is reverse polarity. Now, reverse polarity normally does not have an effect on conventional zones, but on addressable SLCs, it does. If the polarity gets flipped anywhere in the circuit, it'll take the loop down. You won't be able to communicate with any devices because the data will be flowing in the wrong direction. It's kind of like if you have a 2-lane road like this, and exactly what's going on here, how they got the road blocked. If you were to invert the positions of the lanes, your cars would be crashing into each other. And we don't want that to happen. So, good job, construction guys. You were perfect for my explanation. Perfect timing for my explanation. Anyway, so yeah, reverse polarity and short circuits can't have them on an SLC. However, SLCs have one advantage over conventional zones. You can T-tap them. And for those who don't know what a T-tap is, and I just ran that light. Don't tell anybody, please. For those who don't know what a T-tap is when you tap a circuit onto another circuit without providing a return path. Essentially, if you got a wire going like this, alright, and you go right in that wire, like you make a three-way splice, that would be a T-tap. Now, on a conventional zone, you have the end-of-line resistor at the end of the circuit, but if the connection gets broken anywhere along that T-tap, you won't know about it. It's not going to report it. So, yeah, you can't T-tap a conventional zone because of that reason. However, an SLC, since every device is monitored at the device level instead of at the circuit integrity level, you are allowed to do T-taps, which is handy for new installations because it can simplify the amount of wiring needed to be run, which is also very convenient. So, wow, that motorcycle's got bright lights. Anyway, so yeah, that's one of the advantages SLCs have, is you can T-tap them. So yeah, that's basically the basics. Basically the basics of addressable system wiring, design, and components. Probably in another video I'll get into how addressable systems are programmed and maintained, which can get kind of interesting. Although I'd kind of rather do a hands-on video demonstration with the panel than trying to explain it in the car in a fun facts video. So, well, I guess that's about it for this video. Remember the trivia question and put an answer in the comments. Ooh, I should do a challenge question sometime. The big challenge question. I should do a big challenge question where the first person to get it based on the time the comment was posted will win a prize, and the prize will be some alarm device. Depending on how good their answer is, will depend on how good of an alarm device they get. So, we'll see. But I can't think of any challenging questions right now. So, if I ever come up with one, I'll present it in a video and go from there. So, everybody, have a great evening. As you can see, it's evening here. The sun's starting to set, and everyone have a great evening. Goodbye.